Okay, so this video is option C, freshwater from IB Geography, and the syllabus point is environmental consequences of agricultural activities on water quality to include pollution, eutrophication, and irrigation, salinization, and case studies. Okay, so first of all, this is what we're going to separate this into. First of all, we'll go through pollution, eutrophication, then we'll go through irrigation and salinization, and then we'll do the case studies. So, eutrophication. So this source from the BBC Bite Size, shows the steps of eutrophication, which you probably already are aware of because you kind of do it in biology as well, in like GCSE. But basically, nutrients load up from fertilizers in agriculture. So farmers use fertilizers and pesticides to like increase their crop yield and maybe make their crops more efficient somehow, and that can lead to excessive nutrients going into the river through agrochemical runoff from the land into the rivers, and so they're now in the water sources. And then this kind of excess nutrient source leads the plants to flourish, and then algae grows excessively, and this is known as algal bloom. And also duckweed and other plants also grow like just very excessively on the surface of the water. You'll see like this layer of algae, and then that results in a depletion of oxygen, and then it also leads to sunlight being blocked from all of these organisms inside, like under the water. Basically, these will not receive any sunlight, so then they die, and oxygen in the water is depleted. So the like ecosystem kind of is dying at this point. And decomposition in here, like in the deep layers of the water supply, like a lake or something, further deplete the oxygen. Dead plants are broken down by bacteria decomposers, and that uses up even more oxygen in the water. Then finally, the ecosystem basically dies. Oxygen levels reach a point where no life is possible, and then all the fish die. So it's really bad. Basically, like everything just dies because of like agricultural practices. Okay, so that's eutrophication and basically like agrochemical pollution. And now we're going to look at salinization in terms of irrigation. So basically, well, this diagram isn't like directly related to irrigation, but I will try to make it clearer. So basically, here what happens is it's quite similar to the case of deforestation or like clearing of land, because basically when you create irrigation systems, you drain the water and you take maybe water from aquifers, from the groundwater store, and then that leads to a possible increase of the water table. And basically, as you draw up water into the like a higher surface level, it can evaporate. And if water evaporates, it leaves behind salt, which then obviously leads to a very dry and like overly salty like layer of soil, and then that makes the soil very dry and like difficult to raise crops on anymore. So basically, and also makes it very susceptible to erosion, so that basically damages the soil quality and deters any like continuation of growing crops. Okay, finally we have our case study. So we're going to look at 3 different case studies to show the role of different stakeholders in terms of eutrophication and salinization and just environmental consequences of agriculture. So first of all, we'll see Lake Chad. Okay, so what's happening at Lake Chad? Well, there's an uncertainty in the fishing industry, which is a huge industry. Climate change is impacting the events of drought and worsening it. Species are vanishing. Thick vegetation has led to the tangling of nets, so that deters from fishing. There's also become a need to ration water supply. There's like certain days that people can farm because of this need for rationing. They used to have slash and burn practices, which can actually contribute to the idea of salinization. Okay, so solution to that is that there's been hot meal distribution by the World Food Program. This is not a solution, but Boko Haram's presence as a non-state actor led to 14,000 refugees, and they also built a diversion of $6 million, which possibly was a way to like redirect water supplies to where it was needed. Okay. And then we have California. So California has suffered from years of drought and wildfires, mega droughts, and they also have a large agricultural industry, so that links to the idea of eutrophication, and drought kind of links to salinization, as it might exacerbate the process of evaporation, leading to more salty surfaces of soil. It is also on a fault line, so that leads a big earthquake risk here. There are aquifers that have been like kind of depleted, and they take 50 years to refill, such as the Central Valley Aquifer. The water like in the ground that they've drilled to like fulfill their need for water is 20,000 years old. So these obviously take years and years to regenerate, so they are depleting them possibly quicker than they're using them, or quicker than they can restore themselves, I mean. There's also urbanization, economic growth, so more demand for water, placing more strain on it. And they have also, as a solution, created a $500 fine for anyone who wastes water. Finally, we have Kunming City in China. So the Dianchi Lake is susceptible to blue and green algae as a result of agrochemical runoff. And this has killed over 90% of fish, mollusks, and weeds. And the fishing industry has declined. It supplies 1.2 million people. And in 1993, a sewage plant was built, but only manages 10% of the sewage. So it's not like a completely viable solution.